Hello everyone. Today we will be solving the 1988 IMO Problem 6. Let a and b be positive integers such that ab plus 1 divides a squared plus b squared. Show that a squared plus b squared divided by ab plus 1 is the square of an integer. Here's my implementation, or the way that I solved it. So I assume that this equation is equal to y, and y has to be a perfect square based on what they gave us. And then basically what I use is contradiction to solve it. So by contradiction, assume that y is not a perfect square, and without loss of generality, assume that a is greater than or equal to b. This is the smallest solution to the equation above. Then what I did was I cross multiplied, so a squared plus b squared times 1 is equal to y times ab plus 1. And so a squared plus b squared is equal to yab plus y, and a squared plus b squared minus yab minus y is equal to 0. Basically, I just move these terms on the right hand side to the left hand side to make it a quadratic equation. So I am assuming that the solutions to this quadratic equation are a and a2. Then I replace the a with the x, and then I get that x squared minus byx plus b squared minus y is equal to 0. Essentially, it's the same equation as this, but I just replaced the a with the x. And then I just move the terms together in a different way. So then I know that the solutions to this quadratic equation are a and a2. So I can say that x minus a times x minus a2 is equal to 0. And the solutions are a and a2, so I can say this. And then I can expand this whole thing out, so I get that x squared minus a2x minus ax plus a times a2 is equal to 0. And then their x is common in these two, so in these two terms, so I can take the x out, and I get that x squared minus a plus a2 times x plus a times a2 is equal to 0. And then I'm going to use Vieta's formulas. So if you don't know what Vieta's formulas are, I suggest you watch either one of the videos on this on here, or you can Google it up really quickly, because I will not be explaining Vieta's formulas in this video. So the sum of the roots are a and a2. The sum of the roots is equal to by, because remember, it's the negative of negative by, which is positive by. And then I get that a2, I can isolate a2, and I get that a2 is equal to by minus a. And then to solve for the multiplication of the roots are a and a2, so I can multiply both the roots. A times a2 is equal to positive of this, so a positive b squared minus y. And then I can divide by a on both sides to isolate a2, and then I get that a2 is equal to b squared minus y divided by a. So here, an observation that I can make is that a2 is not equal to 0, because y is not a perfect square. Because we're assuming by contradiction that y is not a perfect square. That means that a2 cannot equal 0. Then what I did was I substituted a2 into the equation. So then I get that a2 squared plus b squared divided by a2b plus 1 is equal to y. And then an observation that I can make is that this whole thing on the top is always going to be positive, right? Because even if a2 or if any of these terms, because we know that b is always positive, and if a2 is negative, this whole thing becomes positive. So this whole thing is always going to be positive. And another observation that I can make here is that a2 is going to be positive because b is positive and y is positive. Because remember, y is the square of an integer, so that means that y is positive. That means that a2 has to be positive. So initially we assume that a is greater than or equal to b. So I can square both sides. I get that a squared is greater than or equal to b squared. Then a squared is greater than b squared minus y. And then a is greater than b squared minus y divided by a. Now if we go back up here, we see that b squared minus y divided by a is equal to a2. So I can quickly substitute that in, and I get that a is greater than a2. This contradicts our assumption that a is the smallest, because a is greater than a2. So that means that by contradiction, y has to be a perfect square. If there are any problems or any errors with my solution, or if I made any mistake, please let me know, because I might have made a mistake here and there. Thank you so much for watching.